The problem we're covering today is one with a tricky prompt but a simple solution. It's often used to make sure interviewees question the requirements. This is AlgoDaily. Let's dissect the majority element problem. So, a majority is defined as the greater part or more than half of the total. It is a subset of a set consisting of more than half of the set's elements. So in this first example, we have a simple array with only 3 elements, 4, 2, and 4. We may assume that any input array we get is at least length 1, like in this case. So out of 4, 2, and 4, the majority element is clearly 4. I want to make the distinction here that majority is not the mode. The majority element needs to appear over 50% of the time. So for example, if we were to modify this input array and make it this, there's no longer a majority element because neither consists of more than half of the set. In this example, there's also no majority element, despite the fact that 4 appears 1, 2, 3, 4 times. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 total elements. So it still doesn't constitute the majority, even though 4 is the mode. All right, so how do we go about finding the majority element? Well, with most arrays, I think the first thing that people will reach for is some form of iteration through the array. So knowing that we can use a for loop to go through every element in the array, the first immediate thought that most people have might be to iterate through each element and then find the number of occurrences for each element and then compare that number of occurrences with the total number of elements. So in this case, if we were to follow that strategy, we would start at 4, note that 4 has 1, then iterate through and look for 4 again, and we find it one other time. And so we'll record that 4 has 2 occurrences. Then we'll look at 2 and look for the number of occurrences of 2 within this array, and we'll see that it only occurs 1. Then we'll compare this number against the total number of elements, which is 3. And in this case, we know that 2 is greater than 1.5, which is half of 3. Of course, this is a very slow approach because the time complexity is O of n squared. We have to iterate through each element, and then at each element, we're going to be looking for the number of occurrences, and that itself is an O of n procedure. Now, let's look at the second example. We have 4, 2, 2, 3, and 2. From a quick visual scan, you can already see that 2 is the majority element. But how do we know this? How can we tell this in a more straightforward way without having to go through the procedure of looping through the array twice? Well, notice what happens when we sort this array. So notice when we sort this array, over half of the array visually is filled up by 2. You might notice that we can use an interesting property about the majority element. If it constitutes more than half of the elements in the array, that means at the median mark, the element that's present at the median mark will be the majority element if sorted. And this is intuitive because visually, let's say we separate it into 2 parts, the ones with 2s and the 3s and 4s. You can see that because 2 is the majority, it takes up half the space, and as a result, every majority element will always end up at the median mark for an array. And the cool thing is this is a much faster way to find it because we just have to sort. And most sorting algorithms are n times log of n, and thus is much faster than O of n squared. So as usual, let's take a look at the code. So we have a function, majority element, that takes an array. What we can do is we can just sort the array and then find the number at the median, and that'll be the majority element.